Hey, welcome everyone to our CNT125 Voice over IP lesson. Today we're going to be talking about Unified Communications. It's our Voice over IP. We're going to be talking about the public switch telephone networks and so on. So, without further ado, let's go ahead and get started here. All right. So, Unified Communications. Okay. As we begin, okay, I want to ground everyone in where modern communications or unified communications actually came from. Well, they came from the public switch telephone network, or the PSTN. Okay, it is the traditional phone network. Okay, that carried voice and fax for decades. It's a circuit switch model, meaning we had a dedicated electrical path between two endpoints before any communication could actually happen. Think of it like reserving an entire lane on a highway just for your car. No one else can use that lane until you're done with that lane. It's reliable, it was your lane, okay? But it would be incredibly inefficient in today's standards. So, switching is the mechanism that determines how connections are created. So, in circuit switch networks, the connection must be established before any data can move. In contrast, packet switch networks break the data into small little packets and then send them independently. This is the foundation of modern voice over IP and unified communication networks. Hang on one second here. So, all right, so the biggest advantage of packet switching is efficiency. So instead of holding a dedicated line open, packets will travel only when needed, sharing bandwidth and with other traffic. And this is why Ethernet networks and the internet, both packet switch, became the backbone of modern communication. So unified communication builds on this by integrating multiple services, web access, fax, email, voicemail, instant messaging, voice calls, and even video conferencing. The key idea is what we call convergence. And that's when all those different things that we just talked about, web access, fax, email, voice, instant, they're all basically coming into one of our technologies, the internet, right? So the our data communications, the key idea is that convergence, one network carrying many forms of communication. So with IP telephony, okay, the question is, okay, what is IP telephony? What does it mean? Okay. IP telephony, or voice over IP, refers to any network carrying voice using TCP/IP. It can be a private network like a corporate LAN. It can be a public network like the internet. The important point is that voice over IP runs over any packet switch network. It can be running over DSL, it can be running over cable, it can be running over fiber, LTE, satellite, and more. The flexibility is why voice over IP became so widespread. As long as you have IP connectivity, you can carry voice. So, so why organizations implement voice over IP? Okay, three major reasons really. It's cheaper, access to enhanced features, centralized management of voice and data. Traditional analog phones send and receive analog signals, and they might require like an analog telephone adapter, okay, or some kind of gateway that can convert the analog into those digital packets. Some organizations still use PBXs, is the public branch exchange, or they have an IPBX to integrate with their current voice systems. Okay. The IP telephones themselves are purpose-built. They transmit and they receive only digital signals. They connect directly to the network. Soft phones are a little bit different. Soft phones are computer-based. They take things a little bit step further. They're extremely common today because they're inexpensive, they're flexible, and they are easy to deploy. Okay, here you can uh, see just an example of how we would have an IPBX. Okay, IP phones going to a router on our local networks and then heading out to the internet to make our actual calls themselves. Right. Video over IP is very similar to the whole wonderful world of voice over IP. Video conferencing allows real-time collaboration with audio and video. Cisco back in 2018 said that nearly 80% of all of internet traffic is going to be video. Okay, and for the most part, if you think about it, that's come true, right? Key drivers for it. Okay, there's massive amounts of video content out there. There's more and more devices out there capable of streaming. Bandwidth is getting cheaper. Okay, that sets the whole stage for understanding why video over IP is so critical in unified communications itself. Streaming video is one of the most simplest video over IP applications. Okay, we've got video on demand. Stores files on a streaming server like Netflix, YouTube, then allowing users to watch whenever they choose. Live stream a little bit different. Live streaming sends video directly from the source to the viewer in real time. There's usually a delay. For example, if I stream something over YouTube, there's usually like a 15-20 second delay because my data has to go from my location through the internet to the YouTube servers, and then out to those who are receiving it. So here you can see we got the two major categories of streaming. We've got live stream and video on demand, and you're going to learn later that they're going to use two separate different protocols. Okay, you'll notice that the video on demand, there's little arrows coming back. It's setting everything up in different packets. Okay, so the content stored in the streaming server, users request it when it's convenient, and the server sends it over the network. Those little arrows, there's hundreds of little arrows coming back. Those are packets, okay? Live streaming is sent directly from the source to viewers with minimal delay, okay? So you can see it's just one steady stream going to and fro, okay? So there, I'm sorry, I was a little behind on my caption there. So there's my line, there's my hundreds of packets coming back across, okay, on my video on demand because I'm using a different protocol. And here I just have my live stream going back and forth over and above. Right. So next, we want to look at we have unicast and point-to-point and point-to-point multi-streaming is what we want to discuss here. Here we want to focus on how video streams are delivered. So unicast means that it's one stream per viewer. Okay, it's very bandwidth intensive. Point-to-point means that it sends the same stream to many users, but it's not the same as like a multicast. Most streaming video today uses unicast over public network, which is why content providers themselves need such massive infrastructure, because we just got done saying that unicast means one stream per viewer, and it's very bandwidth intensive. That's why when you go shopping for Comcast, and they'll say, well, you need to have a bigger pipe to get higher bandwidth. So video conferencing, okay, differs, okay, from streaming because it's interactive. Participants will send and receive their audio and their video. They'll do it simultaneously. And the benefits of doing this is for real-time collaboration. Reduces your travel costs. Faster collaboration. I can get instant feedback. It's more flexible in communication. I can do it on multiple devices. I can do it on my phone. I can do it on my PC. I can do it on a tablet. I can do it on a Mac. I can do it on Windows. I can do it in Linux. Right? Think about when we use Zoom and we use Teams or you use FaceTime. Okay, those are all different video conferencing techniques. Video conferencing is used in telemedicine. It's used in education. It's used in the court systems. It's used with surveillance, okay? All you need as a user is a device capable of generating, receiving audio and video. Typically a workstation with a camera and a microphone. Or maybe a dedicated video terminal, okay? Is all you need to communicate in video conferencing itself, right? What we're looking at here is nothing more than just a voice over IP phone, which has the capability of actually doing video conferencing, right? Key features here, if we look at the back of this, you would see that it has Ethernet ports instead of a phone jack. It would have typically two ports, one port to go to your PC to give your PC data, another port that would connect directly to the switch. Like the ones we have in our classrooms. This uses power over Ethernet. So I don't even have to plug this into a wall to get electricity. It integrates with SIP, the Session Initiation Protocol, or other proprietary systems based if you're using Cisco or whatever. A video bridge will help manage all the multiple sessions that might be going on in your company's network, okay? Allowing participants to see and then hear each other, okay? Think about when we're in a Zoom session, okay? And you can see each other's screens, right? These bridges can be a hardware appliance. They can be cloud-based services, right? It really just depends on your current infrastructure. They rely on a signaling protocol to coordinate the sessions. Right? And the signaling protocols themselves, what do they do? Okay. Well, signaling itself is the exchange of information. It sets up and it manages and it terminates the communication sessions. Each early voice over IP systems use proprietary protocols. But today we rely on standardized ones like SIP and H323. This graphic here just really just sets the foundation for like how the calls are established, really. Okay. H323 is an ITU standard. It manages multimedia sessions over a packet switch network. It supports voice and video. Key components might be, has terminals, has an H323 gateway, has gatekeepers. It has a multi-point control unit. It'll have different zones, basically networks, okay? H323 is probably one of the earliest and one of the most comprehensive of the voice standards out there. If we take a look at the graphic here, you can see that we have the MTEC multi control unit, which allows us to break up each individual call. Think about it. In this graphic here, you've got 1, 2, 3, 4, 5, 6 H323 terminals. See, that just means we've got or 5 323 terminals that are just basically, everyone's got their own session going on, and the MCU, the control unit, helps break it up so that everyone else is getting their own individual feed, and then the gateway is what's taking it out to the internet or the public switch telephone network to be used, to be viewed. The H225 and H245 signaling, okay, are a little bit different. The H225 handles our call setup, while the H245 manages the media control, like negotiating those codecs. So if you don't know what a codec is the compression and decompression. So the packet itself is huge, so we have to make it smaller for transport, and then when we get to the other end, we have to decompress it. So we compress it and then decompress it at the other end, and we have to have a codec that is able to work with the type of packets that we're sending. A SIP session, okay, is an application layer protocol modeled on HTTP. It's modular and it's lightweight and it's easier to implement than H323. It handles session management and enhanced services, but has fewer built-in capabilities than the H323. So, for example, the early SIP packets that we had, they couldn't do caller ID, right? But current ones can. The way it gets built, the way it gets set up, we have to have an agent out there and a client out there and a server out there and a registrar and a proxy server, because the proxy server goes out and gets stuff for you, and then everything gets redirected, and each one plays an individual role. So if we were to take a look at it this way here, you can see that the user agent itself initiates the request. Okay, and then the proxy server routes that request within the SIP domain, and the registrar and redirect servers, they might help assist in finding out, okay, I'm trying to get to this client, I'm trying to connect this call with this individual client. So the registrar and redirect servers would assist in locating the recipient of the call that we're trying to get, or maybe sometimes we had to take it off to another domain to communicate with. Here, it's just we have to look at what the advantages are, okay, of SIP. Okay, one, it's just easy. Okay, it's easier to set up. Okay, it's easier to be used. There's fewer instructions per call. Okay, H323 also SIP over H223 consumes less processing power, and it's just more flexible. Okay. Both, however, regulate the call signaling. Both control for voice over IP, and clients both have the control over the voice over IP or video over IP clients and servers, and they do not account for communication between the media gateways themselves. All right. Speaking of the gateway, now we have the Magaco, okay, and the MGCP. All right. The MGCP, the Media Gateway Control, remember I said it's what's helping us break up it's helping us break up our session. Okay, the Media Gateway converts the public switch telephone network signals into that VoIP format. Okay, they are both protocols that allow the Media Gateway Controller or soft switch to manage multiple gateways. These protocols are separate from the signaling from the media and improving. These protocols both separate signaling from media, improving our scalability, giving us the ability to grow as the network grows. The MGCP is older. It is used in multi-service networks. It works with SIP or H323. The MGC centralizes control, making it easier to manage large voice over IP deployments. Okay, and here's just a graphic of how the public switch network, we have our gateways, okay, accepting the data coming in, okay, from the public switch telephone network, then gets to be broken up to be turned into voice over IP packets, and then goes out to the internet and back and forth. Okay. Magaco is newer and is more capable than the MGCP. The Magaco does support ATM networks and was jointly developed with the ITU and the IETF. The voice over IP has evolved towards a much more flexible and scalable architectures as we have used it over and over more and more. Now, we talked earlier about the video on demand and the live video, and this is really where the transport protocols come into play when we're looking at TCP versus UDP. Voice and video payloads will use different protocols based on what they're doing. TCP will guarantee delivery, but TCP will introduce a lot more delay into those packets. UDP, however, is connectionless and is faster. So it makes it ideal for real-time applications like that live streaming, as opposed to video on demand, which gives us the capability of using TCP, because I can read my data as it comes in, checks to make sure that all the data is intact, and if I need to, I can go back and get more packets. And it puts it all into a buffer. Because you only need, most of us are sitting back with 100 to a gig of speed of service, and we only need 25 meg of service in order to stream 4K video. So with that extra speed we got going, we actually have the capabilities of buffering and keeping a lot of data into our memory. Real-time protocol, on the other hand, as the name suggests, it's what's going on right now, operates at the application layer, and it uses UDP. It'll add sequence numbers and timestamps so that the receiver can reassemble a packet. Now, if I have a packet that's really coming in out of order, it just gets discarded. We're not going to throw it into the mix and then have some weird skip into our feed. It has the ability to compensate for some of that delay, but it doesn't guarantee delivery. It simply provides the structure needed for those live streams. In summary here, okay, we want to look at how the real-time transport control protocol, it gives us feedback about quality control. It has packet loss and jitter, gives us information about delay. It's optional, but it's extremely useful when we're monitoring performance, which has a lot to do with our quality of service. Together, the RTP and the RTCP, they maintain the media quality even though they can't correct transmission flaws. To wrap it up, okay, Unified Communications integrates many services over IP. Voice over IP relies on packet switching for efficiency. Signaling protocols handle call setup and control. RTP and RTCP actually carry the actual media itself. And this is where you want to take a look at what it is that we do, what it is that you use every day. You use Zoom every day. You use Teams every day. You use FaceTime every day. You use other streaming platforms every day. How does this information that we covered here, okay, how does this incorporate into your everyday life to help you get a better understanding of what it is that we just discussed? Right? That concludes our little lesson here today. And then, I'll see you guys all shortly.